Okay, folks, last learning goal of this module. This should be a pretty short and sweet one, talking about the Ehrenfest classification of phase transitions. Let's go for it. So the Ehrenfest classification is divided up into two things. First order phase transitions, and then in the next slide, we'll see that there are second order phase transitions. So a first order phase transition means the first derivative over a transition is discontinuous. Okay? So if we look at all of these different things like volume, enthalpy, chemical potential, entropy, heat capacity, we can see a notable change occurring where that phase transition happens. So for example, we can see a huge jump in volume going from one phase to another, which shows a discontinuous first derivative, right? Similarly, we can see a huge jump in the enthalpy. Notably, right, that's related to our, I wrote delta H of vaporization, but it not necessarily is vaporization, right? That is our latent heat, okay? So the chemical potential shows a little bit smoother of an effect, but remember that chemical potential shows that line because, you know, one phase, this line will continue smoothly that way, and the other phase, this line will continue smoothly that way, right? So the phase with the lowest chemical potential is the one that is observed. Similarly, we see a big jump in entropy corresponding to the delta S upon the entropy change. And now resultingly, if we look at the heat capacity, and by the way, hopefully this was notable here, temperature is the x-axis on all of these scales, right? The temperature at which the phase transition is occurring. So the heat capacity at a first order phase transition is technically infinite at that brief spot. So in other words, you're pumping in heat without a temperature change. So we see a huge spike in heat capacity that would be recorded like on a differential scanning calorimeter, right? Those are those big peaks that we've looked at, okay? So as you might guess, these first order phase transitions occur, or I should say first order phase transitions are more noteworthy transitions, right? Like a solid going to a liquid or a liquid going to a gas. Things where there are these large scale changes, okay? So now if we look at second order phase transitions, and of course worthwhile to note here, the first derivative is continuous, but the second derivative is not continuous, okay? So now looking at all of those same things that we just looked at, volume, enthalpy, and the like, we can see it's a much more subtle change for these second order phase transitions, right? So there is no latent heat observed in a second order phase transition. Chemical potentials continue along smoothly. There's a little bit of a change in entropy, which would give a discontinuous second derivative, but a continuous first derivative. And the heat capacity does show a little bit of a jump there, but certainly by no means jumps up to infinity at that one particular spot. So second order phase transitions are typically solid to solid phase transitions. Things like crystal structure changes that aren't considered large scale. The glass transition temperature is a second order phase transition. Helium going from a fluid to a superfluid is a second order phase transition. So these second order phase transitions are rare. And now if we look at them together here, comparing the first order to the second order, we can see those big differences, right? In the first order, there was that large jump in volume where we don't see that in the second order. And similarly, we have a latent heat in the first order phase transitions, but no latent heat in the second order phase transitions, okay? So we'll more commonly see first order phase transitions, right, in your day-to-day experiences. But for those like noteworthy, really cool, novel materials that we might be synthesizing for energy storage or to do some cool job that we might not be able to think about at present moment. So getting into all these weird things like nanotubes and nanostructures and all that good stuff, those will typically undergo second order phase transitions. All right, folks, that's it for this module. I'll see you in the next one.